All right, we are now going to take a look at while loops, and this is for right here. This is for while loops and if-else structures numbers 1, and this is the while command. So just a few things about while loops. A while loop is a structure inside of robot C. It allows the selection of code to be repeated as long as a certain condition remains true. So there are three main parts to every while loop. The first main part is the word while, and that's right here. The second thing is the condition. And the third thing is the repeated commands. And the repeated commands go between these curly braces. So every while loop begins with the keyword while. So you put in the while. Actually, this is pretty simple. Don't get hung up on making mistakes with brackets and stuff like that. And the reason I say that is because I'm going to show you how to drag the while loop in so that you get the syntax is correct, and so that the amount of brackets and parentheses are all correct and everything else. Now the condition, which is right here, okay, the condition controls how long or how many times a while loop is going to repeat. So when a condition is true, the while loop repeats itself. When a condition is false, the while loop ends and the remainder of the program executes. So the condition gets checked once every time the loop repeats itself, just before the commands between the curly braces run. So this condition is checked, and then if it's true, then the commands inside between the curly braces actually run. Now the repeated commands. The commands between the curly braces are going to repeat when the while condition is true. The program checks at the beginning of each pass through the loop. Boolean logic is what we're talking with here. Program decisions are always based on questions. So there's only two possible answers in programming, either a yes or no, or a true or false answer. Those are the only two answers to questions in programming. Statements that can be only true or false are called Boolean statements, and their true or false value is called a truth value. So here we have a condition. In this condition, the sensor value, which is the sonar sensor, is greater than 45. So you have to ask yourself, is the value of the ultrasonic sensor greater than 45? That's what's being asked over here. Well, it's true if the current value is more than 45. So, example, it's 50. So that means that the condition is true. It's false if the current value is no more than 45. So, for example, if the value is 40, then this statement here, or this question, is false. So the condition is 1 equals 1. And you ask yourself, is 1 equal to 1? 1 means true. So is 1 equal to 1? It's true, always, and the program is true, or the question is true. If 0 equals 1, is 0 equal to 1? Then you have a false statement, or a false question. Now there are other Boolean logics here. Equals to, here's a condition written out, or the question written out. So 50 is equal to 50. It's true. Is 50 equal to 100? Well, it's false. Is 100 equal to 50? It's false. Then there's others here that we're not going to touch on in this particular example, or at this time. So when you write a condition, and this is what the program is right here, while the bump switch is not pressed, you're going to wait until it's dark, then you turn on the light. wait until it's light, then turn off the light. So the while command is dragged in, and the sensor value, and that is going to be inside of square brackets, is going to provide the input sensor value. So the sensor value is the bump switch in this case, because the bump switch is not pressed, and it's equals 0. So it's not pressed. That's what the 0 means. Then inside the brackets goes the until it's dark, and then the 500 value is for the sensor. Then you have the light sensor. Then we turn the flashlight on at a power of 127. And then when the value turns light, or when the sensor detects light at greater than 500, the light sensor does, then the flashlight turns off. And then we have the closed bracket, and then it loops back up here and looks at, is the bump switch still turned off? And it's going to come back down here. Now, if it loops back up and the bump switch is pressed, so it would be equal to 1, equals 1, then this wouldn't run. It would jump down past this to the next set of bracketed text. So I'm going to show you how to write the program here for this while command. So our while command, and I'll just go right to the program because I've got it written in here. The task description is that the right motor is going to spin forwards at half speed for 3 seconds, then it's going to turn off. And when the left motor then will spin at half speed for 3 seconds and turn off. And then this will loop. Excuse me. So I've taken this and I've created my pseudocode. Right motor comes on at 63, waits 3 seconds, the motor comes off. Then the left motor comes on at 63. It waits for 3 seconds, and then the motor turns off, and then it loops. So whenever you see the word loop, what they're asking for is an while statement. So to get a while statement in here, the easiest way to do is to drag it in. And I'm going to go up here to the plus next to the word control structures. And in here, you'll see a couple different things. One, there is another natural language up here. We'll get to that in another video. But we have control structures. And here is the while condition. And I'm going to take that, I'm going to drag that down between the two curly brackets for the task main. Now, before I do anything else, I want to hit my fix formatting and watch what happens to the stuff that I just dragged in with the while right here. It's offsetted in. And the reason it did that is this curly bracket and this curly bracket are in line. So this is the start of the program. So I can put in start. Start T. Oops. There we go. And then this curly bracket down here is the end of program. And I got to put in 2 slashes. There we go. Okay. So let's do this. I'm going to actually go down here and space that out a little bit just so we have some distance. All right. So we have to set a condition. And we want our condition to be something that is always true. So I'm just going to double click on the word condition here. I'm going to put in 1 equals 1. And you have to have 2 equal signs here that says that something is true. Now the body, right down here, the body is going to be all this pseudocode. So I'll copy from right here where it says motor off. I'm going to copy that, and I'm going to paste it down in here where the body is. Control V. And I'll put my 2 slashes in here for everything. Come on. Okay. And we'll get everything lining up. All right. Now, go back to my fixed formatting. Just keep doing that. And here we go. Okay. Now, gotta start putting in the stuff that's going to run the code. So I'm going to go to my natural language here and movement, and I'm going to drag in my start motor. Okay, I'll just put that in. Oops. Come on, there we go. And the motor port is going to be right motor. And my speed is going to be at 63, so I'll put in 63. Now I'm going to get a weight. So I'll go get my weight. I'll wait for time. Oops. Undo that because I goofed the drag in. Okay. Backspace, 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 backspace. There we go. My wait time is going to be 3 seconds. Oops. 3 seconds. Okay. And then I'm going to stop my motor. And my stop motor is going to be right motor. So I'll just copy this and paste it. And then we're going to actually start motor, and this time here we're going to start the motor. So I'll copy, but this is going to be the left motor, so I got to change this to left motor. And then we're going to wait 3 again, so I'll just copy this. And then we're going to stop the motor. Copy. Control V. And this is going to be the left motor that we're going to stop. Oops. Come on, you. Here we go. Copy. And it's that right motor. We want this to be the left motor. Control V. All right. Fix my formatting. Here we go. So now, this bracket right here, we're going to run through this program, and then it's going to get down here to this bracket, and it's going to say loop back up to our while. And as long as this is still true, then we're going to hop down into our program and run and then loop. So this is the loop part of this. I'm going to copy and Control V. And my 2 slashes. Loop to while. Okay. So let's see. I think I got everything okay. I'll just clean this up by moving that up. Just do the fix formatting one more time. And there we go. Now I'm going to compile my program. And it doesn't like a lot of things here. Let's see, what is it? Stop motor. Check spelling in letter case. So right motor. This is on line 40. So this one right here. Start motor. Right motor. RIGHT capital MOT. OR. Oh, I know why. In this particular case, this setup up here, we didn't change the motor setup. Motors, we didn't capitalize the M's in this one. This is an old template. Motor. Rather going back and changing all those other things, I'm going to see if this will fix it. All right, compile. Yeah, that fixed it. That was exactly the problem. The motor box had the names not camel text typed. Okay. All right. So now we've got it compiled. Let's take and zoom this up. I'll bring this in bigger. And we'll see if this program runs the way I expect it to. Download it to the robot. Looks like my robot's all turned on. Here's my two motors. And now I got to move things a little bit because the debugger is getting covered up. Okay, I'm going to hit start. So it's running for 3 seconds. Then it runs the other one. Then it gets to the end of that, and it just does this so quickly we can't see it. It went back up to the while and said, "Yep, it's still true." So this is I kind of call this an infinite loop, and that's what this is. This won't stop running until the battery dies or until I hit stop on the debugger.